what is the expected output of this line of code in JavaScript? It's one line of code. We have console.log, the string hello space, additive operator, and a numeric literal 075. Console.log hello plus 075. What do you think it's going to be? Let's look at the options given. Could be the string hello 75, the string hello 61, error, or other / depends. We got a comment down below that I left. Console.log hello 075. That occurs on line 34. Why is that all the way down on line 34? That is a hint left there by me. Line 34. What does line 34 matter? Well, it matters that it's not line 1. We're in the middle of a program with some other stuff. So what could possibly affect it? And is that other depends a valid consideration? Should it throw an error? Should it be hello 61? Why 61 when it starts? Well, why does it start with a 0? Well, could it be an octal number? And if it is octal, is 61 the octal equivalent of 75? And how do we figure that out? Without using any console and just copying and pasting it ourselves, let's just think through the problem. Or should it just be hello 75 and interpret that as decimal? Well, how would we know the answer to that problem? Well, if we look at the spec, EcmaScript spec, we can take a look. And I'm going to give you a giveaway here, so you don't have to read the whole thing. The strict mode is a determining factor on how stuff works, how the program's going to run. So this particular code is a line of code. It's not the entire program. So there's a little gotcha in there. So we have to think about this is one line of code on line 34. There might be other stuff above line 34 because it wouldn't really make sense to put a bunch of blank new lines in your code editor and put that all the way down at the bottom. That would be kind of annoying. Nobody does that. There's probably something else in there. Let's look up. Let's scroll up. But we don't get to scroll up because we can't see. So let's see. If it's in strict mode, it might change things. And let's take a look at that. And strict mode, as you should know, is denotated by, at the top of your file, you put in lowercase, use strict. Use strict. And we can see that in the spec up here. Strict mode we got here. And we got this one over down here. We got the directive. Use strict. Use strict directive. There we go. Is the string literal exact code point sequences. It can be single quotes or double quotes. Okay, that's it. It's got to be exactly that. So there's not upper and lower case. It's just that. It could be single quotes. But so if we're in strict mode, we're going to go to this second bullet point. Conforming implementation, when processing strict mode code, must disallow instances of the production's numeric literal, legacy octal integer literal. I'm going to have to take a look at that. Oh, and decimal integer literal, non-octal decimal integer literal. Well, what the hell is that? We're going to have to take a look at these. Legacy octal integer literal and non-octal decimal integer literal. First, we're going to look at this one. Legacy octal integer literal is, as it might indicate by the name, it's legacy. So it's something for old stuff. And it's got a 0 followed by an octal digit, which you can probably guess is going to be 0 through 7. And we can see right down here, octal digit is one of these things, 0 through 7. So that makes it straightforward. Right, so you can have a 0 followed by an octal digit. Or you can have a legacy octal integer literal, which is a 0 followed by an empty digit, an octal digit, followed by another octal digit. So you can have a whole bunch of them. Right, so it's got to be a 0 followed by one of these, or a 0 followed by a bunch of these. That makes it a legacy octal integer literal. And we'll see down below there are semantics for how these things are supposed to be interpreted, but I'll show you how to convert that to octal in a second, so we can see if 61 is even the correct conversion to octal of 75. So we looked at one. We looked at this legacy octal integer literal. And what was the other one down here we got in strict mode? Non-octal decimal integer literal. Non-octal decimal integer literal. It's a 0 plus a non-octal digit. Well, a non-octal digit, that's right here, 8 and 9. Ooh, so if you have a 0 followed by an 8 or 9, then it's a non-octal decimal integer literal. See, that's very interesting, because if you have 0, 7, 5, it's octal. But if you have 0, 8, this is not octal anymore. So 080 would be 80. And 0, 0, 7, see, then you're starting to get problems when we get 0, 7, 9, because that's not going to fall into the production, because then we have to have 0 plus, now we have a non-octal decimal integer literal. So now we have decimal. Right, so if you have 0 plus a non-octal digit, that's going to be non-octal decimal integer literal. Or we can have legacy octal like decimal integer literal followed by a non-octal digit. So that's 0 plus an octal digit plus a non-octal digit, which would be the 079, right? And that's going to be as decimal. So that won't be an error. But it will be an error in strict mode. But it's not an error in sloppy mode. So in sloppy mode, if we've got 075, it's going to be octal. Right? If we had 078, that would be 78. But if we have 075, that's going to be something different. So now we're going to talk about the conversion of octal to decimal. Only to be complete. So we have octal to decimal. Octal is base 8. To change base, to go to base 10, we take the digit times the base to the power of the position. Okay, so let's break that down. The digit in this number, we have 3 positions. First of all, we have position 0 on the right. To the left of that, position 1. To the left of that, well, that's our octal signifier, so that doesn't count as a position. We don't include that. That just says we're doing octal now. All right, that's the production, the grammatical production of octal. What do they say? They call it an octal integer literal. Ooh, and we got something else up here, don't we? Yes, that's for strict mode. That's moving forward. That's being a little bit less sloppy, because copying Java's octal literals was a mistake. That was a big mistake. But back to this. Octal to decimal. 075 position, digit times base to the power of position. So we're going to start from the left, actually. We've got 075. 7 is the digit times base to the power of position. So the position is 7. Well, the digit is 7. 7 times base is 8. 8 to the power of position. Position is 1, which is going to be equal to 56. Okay, and then we have 5 times 8 to the power of 0. 8 to the power of 0 is 1, and that's going to be 5. Right. So we got 56 plus 5 for a grand total. You've already solved it. 61. Aha. So mystery solved. So it's 61 if we're not in strict mode, and it's error in strict mode. In strict mode, it's an error. And we know this because it says so right here. It is a syntax error if the source text matched by this production is in strict mode code. Which production? This production. Numeric literal, legacy octal, integer literal. That's the first one we looked at. Legacy octal, integer literal. 0 plus an octal digit, or it's recursively designed. So you can have 0 plus an octal digit, or 0 plus a legacy octal integer literal, which could be a 0 followed by an octal digit, or we could have 0, 0, 0, 0, 0, 1, and that's going to be 1 in octal. Okay, so it could be either one of those, and if we get a decimal integer literal, that's a non-octal decimal integer literal. It's not octal. Non-octal decimal integer literal. We already went over that. 0 followed by one of these. than that in strict mode, syntax error. Okay, so the answer to this question is, well, it depends if we're in strict mode. So if we're in strict mode, it's going to be an error, a syntax error. And if we're in sloppy mode, it's going to be 61. So almost everybody got this answer wrong. Okay, but going back to the older versions of EcmaScript, it didn't actually specify what would happen in the case for this non-octal decimal integer literal. It didn't have that. With 0 followed by a non-octal, it didn't have that. 0 followed by 8, and it wasn't specified in EcmaScript 3 final, which was like 1998. A squirrel is trying to eat the handlebar tape on my bicycle outside. That's odd. Back to the video. I'd show you guys, making sure you guys right now. I can't get it on there. I can't get it on there. Wish I could get it on there and show it to you guys. There he is. The squirrel is trying to eat the bar tape of my bicycle. So, in conclusion, don't put zeros before your numbers. Oh, and one other thing is, in legacy code, what would happen in older versions of EcmaScript, parseInt would also parse octal numbers. And they changed that, so it doesn't do it anymore. Now parseInt 075 is going to give you 75. It's not going to give you, it's not going to try to parse octal, give you 61. In either mode, it'll give you 75. And the way, if you really want octal, you put the number 0 followed by the letter O, and you can put octal. You can put octal big numbers even. You can have big numbers, and you can separate them with numeric literal separator, which is an underbar. And so you can have, for example, if we were in sloppy mode, we can have, actually in any mode, we can have 0, O, 999. No, we can't have 999. We can have 777, 666, 555. And that gets converted right into decimal in the console. And we could even put that as toString 8. And that'll give us the same thing right back out as a string. So there you have it, folks. A deep dive into something super simple that people seem to get wrong and have troubles and struggle with due to complications of legacy implementation in EcmaScript that was borrowed, imported from Java, a bad idea that propagated for about 30 years from Java to EcmaScript. 2024, we still have this crap in our implementations. That we have to deal with the nastiness of numbers like this, which is 9, numbers like this, which is 8, and numbers like, which is 79, and numbers like 075, which is 61. 61. Right, but 078 is 78, but 077 is going to be 63. So it gets a little bit weird. Thanks so much for watching. I hope this was edifying.